Discern. One of the things yesterday was from got the leak fixed temporarily with the plumber, and I wanted to ask your advice.
Of course. Well, the first thing I'd say is make sure you.
All right. I was discussing about the regression analysis types. In case of simple linear regression, you might have one single independent variable that you are using as a predictor to see its impact on dependent variable. You might have a straight line, you might have a model like this. And in case of multiple regression analysis, you might have multiple independent variables predicting its variation on one dependent variable. The relationship is represented by a hyperplane in a multi-dimensional space, and you would see the model like this. So what is the next thing here we can do? I need to analyze simple regression analysis on my example number 3, but you need to be aware of the data set. The new file is called example3 and consists of a data set in which 73 students. If we go for a normality assumption, as we know that if the number of observation are greater than 30, we consider it as a normal data set. So the normality assumption is fulfilled when there are number of observation greater than 30. So in our case, the number of students are 73. It's mean we have gathered data from 73 students which are greater than 30 observation, which is the minimum requirement for normality. So we need not to check normality over here. In case if your number of observations or your number of sample points are less than 30, you need to check the normality assumption first. So in our case, in our example 3, we don't need to check the normality. So it is stating that the new file is called example3 and consists of a data set in which 73 students are measured on their level of pre-exam anxiety. Whenever the exams come, the student often needs to face the exam anxiety, the pre-exam anxiety before starting the exam. So it states that there is a variable with the name of pre-exam anxiety. It indicates that one shows to severe, one shows there is no anxiety, next shows severe anxiety at 10 scales, and then measured on 100 to point exam. The hypothesis for a linear relationship might be that those with very low anxiety will do poorly because they don't care much, and that those with high anxiety will do better because they are motivated to spend more time in preparation. So here the hypothesis is that with increasing the anxiety level, the performance of the student increases. It means it has told in this example that those students with higher level of anxiety, they basically do much care about their preparation. They are more motivated to spend more time in preparation. So if a person has lesser anxiety, he will not do care or much care about their preparation. So our hypothesis would be with increasing the anxiety, the performance of the student will also increase, and with decreasing the anxiety, the performance of the student will also decrease. So this would be from this statement we can basically create our hypothesis. The dependent variable is exam or exam performance. So this would be our dependent variable, and the independent variable is anxiety, because we want to see the impact of anxiety on the exam score. So we can relate the independent variable with anxiety, and we can consider exam as our dependent variable. In other words, we are attempting to predict the exam score from anxiety score. Among other things that regression accomplishes, it is able to create a regression equation to calculate a person's predicted score on the exam based on his or her anxiety score. So we can analyze our data. We can at first we can create our hypothesis, for example 3. So what would be our hypothesis here? So I can write here null hypothesis as there is no impact of anxiety on exam score. And what would be my alternative hypothesis? There is a significant impact of anxiety on exam score. This would be our alternative hypothesis. When you doesn't have any previous literature on whether it is increasing or decreasing, you may have to create the hypothesis which is considered as non-directional, because these types of hypothesis does not state the direction of both variables. But if you have a theory or a literature that does support whether one variable is positively impacting the other variable, you can make the directional hypothesis. I can make the directional hypothesis from these. You can simply copy them and you can paste them here. I can state the directional hypothesis like the higher level of anxiety significantly increases the exam score. So here basically the positive impact of increasing level of anxiety increases the exam score, and you can reverse this hypothesis as a the higher level of anxiety does not significantly, sorry, we need to use the higher level of anxiety does not here, but not here. I need to copy the statement and just I need to remove the word does not from here. Yes, this one. So now it becomes a directional hypothesis. So this is the directional. You can write over here, and the above two were non-directional. So whenever you does not know whether the independent variable increase or decrease your dependent variable, you may use the non-directional hypothesis. But if you know that your independent variable either increase or decrease your dependent variable, you should preferably use directional hypothesis. But you need a strong support from your literature or your theory. So we need to check it. So we need to use basically example 3 data. We have a data set. Just a minute. I have also shared with you the data set, example number 3 data set. Just use it, and you would see in this data set there is a variable named anxiety, and there is a variable named exam. So both are basically continuous variable. So as I have told you that the number of observation will determine whether we need to test the normality over here or not. So as the number of observation are greater than 30, so we don't need to check the normality of the data. So how can we analyze the impact of anxiety on exam score? You go to the analyze and then you go to the regression, and there is an option of linear. You need to click linear as a option of your regression analysis. Just click it and you will find a box like this, a drop down box or a menu like this. You need to put your dependent variable that you need to predict. Like in our case, we need to predict the exam score on the basis of anxiety. So put the anxiety as a independent variable, not anxiety 2. You just need to use anxiety as your independent variable. Go to the statistic. There are a lot of option here. What we need regression coefficient estimate. We need model fit. We does not need descriptive or collinearity diagnostic at this level, or we also does not need the Durbin Watson over here. I will let you know after some slides or some parts when we have learned the basics. There is a option of plot if you would like to see the histogram or normal probability plot of your residual. You can also use it. There is an option of using probability of f. You if you would like to see whether you would like to use 5% probability value or 10% level, but you does not require to use any of these. You just simply click OK. You does not need to change anything from these options available. You just need to put your dependent variable in the dependent box, and you just need to put your independent variable in independent box and click OK. And you will see four tables like this, and you need to understand each one of them. These three tables are important: model summary, ANOVA, and coefficient table. The first table is not important. It will just show which is your dependent variable and which is your independent variable. The second table, which is model summary table, it will give you some important information, like it will show you what is your R. R is basically the correlation coefficient. As we have two variables, we have dependent variable as a exam, and we have independent variable as a anxiety. So if we like to see whether there is a positive correlation, negative correlation, or zero correlation, we can see the value of simple R. So it is showing a weak positive correlation between anxiety and exam, but at this level we does not require any correlation. Next is R square. R square is basically explain how much variation of your anxiety as a independent variable can impact your dependent variable variation. So how much your how much the variance of your dependent variable is explained by the variance of your independent variable, that is shown by R square. I am repeating again: how much the variance of your dependent variable, which is exam, is explained by the variance of your independent variable, is which is anxiety. So we can say that R square, which is approximately 24%, it indicates that anxiety, the variation in anxiety is explaining 24%, approximately 24%, the variation of exam. Next is adjusted R square, which is more or less equal to R square. As we have one independent variable, therefore adjusted R square is very close to R square. So these both the adjusted R square changes when we increase the number of independent variable, but in our case we have only one independent variable. That's why the values are very close to each other. R square is 23.8%, adjusted R square is approximately 23%. Next is ANOVA table. What we need to see in ANOVA table, we need to see the SIG value. The final column SIG value of ANOVA table is very important. It will indicate whether your model is statistically fit or not. If this value is less than 0.05, if this SIG value of ANOVA table is less than 0.05, it means your model is statistically fit. Next and the most important table is the coefficient table, which will analyze your hypothesis. It will show you the constant in the first row, but it is not important for our interpretation. It will show you the impact of anxiety on your dependent variable exam. And if you can see the value of beta, it is positive value. And if you can see the t value of it, it is 4.710, which is greater than 1.96. And you can also see the SIG value, which is less than 0.05. So what we can conclude here, we can conclude that anxiety, the higher level of anxiety increases the exam score, and it's significantly predicted. So we need to put 3 of these table into our Word file so that we can possibly interpret each one, and you may have an APA interpretation of your results. You need to paste it over here, and you need to also copy and paste coefficient table over here. So how can we interpret? We can interpret one by one each one, like in our model summary table. For example, if we can say that this is our table 3A, because we have created two table before it. It is table 2 and it was table 1. So we can consider it as a table 3A, because 3A I have used because all these results are related to the same procedure, which is regression analysis. So table 3A summary model, table 3B is ANOVA, and table 3C is coefficient table. So how can we interpret? First of all, I need to interpret table 3A, which is model summary table. So here I can interpret it like table 3A indicates the summary of the model. It shows that there is a positive and weak, there is a weak positive and statistically significant relationship between anxiety and exam score, and it is equal to R is equal to 0.488. It is basically the correlation coefficient interpretation, which is this value, this R value. It is basically the correlation coefficient. So first of all, I would like to interpret this value, and if we want to see whether this correlation is significant or not, we can always refer to it, the SIG value of ANOVA. So you can put this same value over here. P is equal to 0.000. So always make it italic, and it shows that there is a weak positive and statistically significant correlation. Use the word correlation, that it will differentiate between the other parts of the interpretation. So I have put here the interpretation of my table 3a first part. The second part, which is R square indicates how much your independent variable or the variation of your independent variable explain your dependent variable. So how can we interpret? We can interpret the table 3a further indicates that the variation in anxiety, which is your independent variable, the variation is in anxiety explains 24%. Actually, if we round this figure, it becomes 24%. Further indicates that the variation in anxiety explains 24% of the variation in exam score. All right, this is the interpretation of your R square, and we don't need to interpret the adjusted R square or standard error of estimate. We just need to interpret only two values from this table, R and R square. So here, this is how you can interpret it. You can put the value of R square over here. So R square is equal to 0.238. So I have put it the rounded figure as a part of interpretation. So this is how you can interpret the table 3a. Now this value is basically indicating that your model is statistically fit. Table 3b indicates that the statistical model showing the impact of anxiety on exam score is statistically fit, and you need to put the significance value over here, which is p or sig dot value is less than 0.05. So this is basically how you can interpret p. You need to use the bracket over here so you can interpret in a technical term. So this is how you can interpret table 3b ANOVA. You just need to interpret only this value, but if this value is greater than 0.05, it means that your model is not statistically fit. It cannot accurately predict your dependent variable based on your independent variable. So you need to be very careful when you interpret your tables. And the third one, that is very most important table, that is the coefficient table. It will show you whether your hypotheses are accepted or not. So what you need to do is go to your hypothesis. If you would like to see the directional hypothesis, just copy these hypotheses from here so that we can check whether our hypotheses are accepted or rejected. We can put it over here. We just need them as a part of interpretation. We does not need them to just make it as a copy and paste over here. So you need to understand how we can interpret. So you need to focus on your independent variable row, and what values you need to see. You need to see your beta value, which is coefficient value. It will show you whether there is a positive impact or whether there is a negative impact. You can also use the standardized value. This beta value is unstandardized. You can use the standardized value, and these are the standardized value. And I would personally recommend to use the standardized value which are more efficient than unstandardized, because unstandardized value may have some standard error, may have more error. So I would personally recommend to use standardized coefficient beta, which is 0.488, and it's still showing a positive impact. Next, you need to see the t value. It should be greater than 1.96, and it is already greater than 1.96 because it is indicating 4.7 value. You need to check next the sig value. The seg value is also less than 0.05. So how can we interpret all these values? I need to write here table 3C indicates the coefficient values of regression analysis along with their impact and significance. So the table indicates that there is a positive. If you can see the value, it does not have any negative sign. It means it is positive. So the table indicates that there is a positive, and if you can see the t value of it, it is anxiety. The t value of anxiety is 4.710, which is greater than 1.96, and also the sig value, which is less than 0.05. So it's mean it is highly significant. So the table indicates there is a positive and highly significant impact of anxiety on exam score of students. So what we can conclude here? We can conclude if the impact is positive and it is significant, it means the increasing level of anxiety basically increases the exam score, which is dependent variable. But if we find a negative sign over here with significance, we can conclude that the impact of anxiety on dependent variable is negative, and we can conclude that anxiety with increasing the level of anxiety, it will decrease the exam score. So in our case it is increasing. So what we can conclude, therefore we can conclude that increasing the level of anxiety can strongly enhance the exam score. So this is basically the possible interpretation. You may also include in this line the beta value and the sig value. So I can put over here like we can use the beta sign from the symbols. This is the beta sign you can use from the symbol. Beta is equal to, as we are using the standardized coefficient, so you need to use the standardized beta coefficient value, which is 0.488, and then you need to put the t value. T value is equal to 4.710, and then you need to put the p value. P value is equal to 0.000. So you need to put the values like this. So this is the interpretation, this is the APA interpretation, and then you can remove the hypothesis. But before removing them, we can include whether our hypothesis is accepted or rejected. You can see that anxiety has positive and significant impact. So let me know whether our null hypothesis is accepted or rejected. Our null hypothesis state that there is no impact, there is no significant impact or anxiety does not significantly increase exam score. But in our case, anxiety is significantly increasing the exam score. So we can reject the null hypothesis and we can accept the alternative hypothesis, because alternative hypothesis state that anxiety significantly increases the exam score. So we can state here our null hypothesis is rejected and we accept the alternative hypothesis which indicate the similar positive and significant impact of anxiety on exam score. So this is the way you can interpret your regression table. So it is a complete interpretation of this table. If you have any question regarding this interpretation, or any point you didn't understand, or any part of it if you didn't understand, you just let me know. So this is how you can interpret your regression table. Yes, this one. Now it is complete interpretation. You need to remove the highlighted from here, no color, so it will make it. And you can also make them like APA style I have previously done. The APA style requires you that you should have a shape like this. You may have an upper border line, a lower border line in the first row, and a lower border line in the last row. So kindly prepare your table when you need to include them as a part of your article. So I hope you understand the interpretation, and please try example number 4 as a part of your interpretation, and I will give you 10 minutes to complete that part. Just a minute. Example 4. First I will let you know how to read this example. Now complete the similar procedure for the two relationships shown in problem 2 from the divorce SAV file. Basically, you need to do this on example number 4. In example number 4, you may have a file in which you may find the influence of closeness close and closeness squared close on life satisfaction. Basically, closeness is the independent variable, influence of closeness or close variable. You may find a variable named close, that would be your independent variable, and you may find life satisfaction in the name of L satisfy. This would be your dependent variable. So you need to check the same procedure, how close impact the life satisfaction, or how closeness impact the life satisfaction. So you need to find out. You may also need to find out attributional style and square of attributional style on life satisfaction. That may be another case. Please, when forming the predictor model, do we use the standardized beta values or standardized beta values? Thanks. I have already explained that you need to use standardized beta values. When you are forming a model or you interpreting your regression, you may need to use standardized beta values, because in publishable articles, when you are going to write your article, your first article, you need to provide the standardized values for interpretation purpose. So hope you find the answer. If anyone having the similar answer, they may ask. There is no question from anyone else. Please let me know. I think there is no question from anyone. Please try example number 4 with these combination I have provided. You have 10 minutes to perform this, and also try to interpret your values also, like I have done. So you have 10 minutes. So if after 10 minutes, if your session completes, because there are 4 minutes and 26 seconds remaining to complete this session, you may need to join using the same link. So take a break of 10 minutes and complete this process. Run your regression by considering close as your independent variable and life satisfaction as your dependent variable, and interpret the table like I have done. Resume the recording. So please join with the same link when the session completes, so that we may start our process, and you may also avail further 5 minutes break, and then we will go towards the final part of our session, which is basically the assumptions, and which is basically the hierarchical